Hi guys, in this video we're going to be looking at how to multiply by tens and hundreds. Now initially this might sound like quite a difficult thing to do, but in reality multiplying by tens and hundreds is actually much easier than multiplying by almost any other number. To start off with then, we're just going to look for a simple relationship when we do the 10 times table. So 1 times 10 is 10. So what I've done is I've taken a 1 and by multiplying it by 10, making it 10 times bigger, we end up with the number 10. Okay, and when we did that, the 1 that was in the units column moved up into the tens column, and then a 0 took that place in the units column. So we'll keep a wee log of these ones down here. 1 times 10 was 10. Let's look at some other stations in the 10 times table. So we're now being asked 3 times 10. So we've got our 3 in the units column. And again, doing the same thing, we're going to move it up one place into the tens column, and a 0 is going to fill the gap. So 3 times 10 is 30. Carrying on then, let's try 9 times 10. So we're going to put our 9 in the units column, but because we're timesing it by 10, it's going to move up one place to the tens column, and a 0 will take the place. So 9 times 10 is 90. We just move everything up one column every time we times by 10. So the units become the tens become the hundreds become the thousands. So let's have a more complicated. So now we've been given 17 times 10. Now 17 is made of 7 units and 1 10. Now following the same process, if I'm timesing it by 10, I should be able to move both of these up one column. I'm having some difficulty doing here. Move everything up one column. So the tens become the hundreds, the units become the tens, and a 0 takes the place. So 17 times 10 is 170. So no matter what, if we're timesing by 10, we just move it up one place. And what we should start to notice is a bit of a pattern. It looks as though we can just add a 0 every time. And this is what a lot of people assume is what we do when we multiply by 10. Right, well yeah, we just add a 0. Well, that's not the case. Why can't we just add a 0 though? So back here, if we look at our working down here, it looks like every time I'm just adding on a 0. It's a 1, so 1 times 10 is a 1 with a 0 on the end. 3 times 10 is a 3 with a 0 on the end. 9 times 10 is a 9 with a 0 on the end. This doesn't work though if we're doing decimal numbers. So, for example, let's say I'm doing 0.6 times 10. So 0.6 times 10. So I've got a 0 in the units column. I have no units, but I have 6 tenths. 6 tenths. If I think that I can just add a 0 on the end every time, what I'm going to get is 0.60, which is the same number as 0.6. That is incorrect. Just adding a 0 on the end is not the correct way to do this. It does not bring you to the correct answer. So instead, let's stick to the strategy that we've already realized works. Everything is going to move up one column. So we have 0.6. It's going to, the 0 can move up into the tens column. The 6 can move up into the units column. Now, 0 tens, we can just get rid of that. That doesn't actually matter. So 0.6 times 10 is the same as 6, quite simply. Similar rule here, 1.7 times 10. Can't just add a 0 on the end, that's not going to make any sense. It would just be the same number. So instead, everything moves up one place. So the unit becomes a 10, the tenths becomes a unit, and so we get 17 in this case. And this will work no matter what the number. So here I have 3.624 times 10. Now every one of these numbers is going to have to move up one place. So the 3 is going to become a 30. The 0.6 is going to become, if I don't warp it out of shape, a 6. The 200ths are going to become 2/10ths, and the 2000ths are going to become 400ths. So what we get instead, 3.624 times 10 becomes 36.24. The numbers all stay the same. It is just the place value that changes. So we've looked at multiplying by tens there. What about hundreds? Well, let's do the same thing as before. So this time we're going to have 1 times 100. Okay, so I've got my 1 unit here. If I times it by 10, it's going to move up to the tens column there. But I'm not timesing it by 10, I'm timesing it by something that's 10 times bigger than 10. I'm timesing it by 100. That means I can't just move it up one place. Because 100 is 10 times bigger than 10, I have to move it up 2 full places. And zeros fill any of the gaps. So 1 times 100 is 100. 3 times 100, the same thing happens. It moves up 2 places, and zeros fill the gap. So 3 times 100 becomes 300. And it will be the same for 9 times 100, equaling 900, and 17 times 100, which becomes 1,700. And again, you might be thinking, well, we're just adding zeros on. But to hammer this home, that's not the case. So here's 4.2 times 100. If I just add zeros on the end, I'm still just going to have 4.2. That's not going to work. So instead, we use place value. I'm timesing it by 100, which means I'm going to move it up 2 places. So the 4 is going to move up 10 to the 100. The 2 is going to move up to the units and the tens, and any gaps can be filled with a 0. So 4.2 times 100 equals 420. So the pattern we should have noticed then is to do with how we move things up the columns, how we change the place value of something. So if we're timesing something by 10, everything moves up 1 place. So it's moving up to the left 1 place. If we're timesing by 100, we move everything to the left 2 places. If we were timesing by 1,000, which we haven't covered in this video, you can probably work it out though. If we were timesing by 1,000, it would be the same thing. We'd be moving to the left, but it would be 3 places. So all you have to do, the only thing you have to remember when it comes to multiplying by tens, hundreds, or thousands, you don't have to know your times tables for it, because you keep your numbers exactly the same. You simply move things up the correct number of columns. Cheers, guys!